Hey, what's up? It's Jake from Nimbus DevOps, and I'm here today to talk to you about method resolution order. So by now you know that when you ask for like some object dot attribute, that the attribute is not found on the object. Python starts searching in the class that some object is created from. If it's not there, it'll just search up the inheritance chain until the attribute's found or the object class itself is actually reached. It's quite simple to understand if the inheritance chain is only made of single inheritance steps, which means the class only has one parent all the way up to the object. However, when multiple inheritance is involved, there are cases when it's not as straightforward to predict, well, what will the actual next class be when it's searched for if an attribute isn't found. So Python provides a way to always know the order in which classes are searched on with the attribute lookup, and it's called the method resolution order, or MRO. And it's basically just the order in which base classes are searched for. That's really all it is. So in the previous example, when I was doing stuff with like squares and polygons and like this multiple inheritance thing, you can see the class for this. Okay, so let's take a look at the MRO for the square class. Okay, so if I said print square, oh come on, square dot class dot and then MRO is what you would use. So let me go ahead and comment all this stuff out because my plot thingy is going to do nothing. And let's see, where do I want to put? I really only have, let's just define that like that. So if I run this, like what do you think is going to happen? Python multiple inheritance. Class, main, square, class, main, regular polygon, polygon. So this is like, it starts at square, then it just goes through here all the way down to the object. So I could have used square dot underscore MRO or square dot MRO, like square dot MRO like this. You could do that too. But you'd have to do it from an instance. You'll have to derive its class dynamically. So in this case, note that the only point of doubt is the bifurcation after polygon, where inheritance chain breaks into two ways. One leads to shape, and the other leads to plotter. And we know by scanning the MRO for the square class that shape is searched before plotter. And you can see that because it's like step 1, step 2, step 3, step 4, step 5, step 6. And you can see shape here is searched before plotter. Okay. Um, why is that important? Well, think about like some code where you have a math problem, right? You have a math function, and like step 1 produces a result, and then step 2 takes that result and produces another result, and step 3 takes that result and produces another result, and so on and so forth. And if your inheritance doesn't go in the order that you think it's going to go in, you're going to end up with the wrong answer, right? Um, and that's basically the short version of it. So in some cases, that's really, really bad when the order matters. So let me show you an example of a simple MRO file. So mro.simple.py. Okay, so let's say that I have a class called A, and I'm just going to say label equals and then a string A. And then I make a class B. I make a class B that takes an input A, big A, caps lock is on, and it just sets label equals B. Okay, and then I take class C, it takes input A, and I make label equals C. And then finally, I will make a class D, which takes B and C, and it says pass. Okay, so B and C inherit from A. right? B and C, they inherit from A here. Okay. Um, and D inherits from both B and C. This means that the lookup for the label attribute can reach the top A through either B or C. According to which is reached first, you would get a different result. Because if you were to print D, if I said D equals D, and then I said print uh, print D dot label, what's it going to print? Well, if D takes B or C, it could be B or C, and depending on B's value or C's value, you could get B or C. And one of those might be wrong, right? So you can learn that MRO, what exactly this is going to do. So if I said, let's see, let's just do Python MRO to simple and Python MRO. It says B, 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 B. Okay, well, apparently it's B. It's always B. It's always been B. It's always you, B. Well, why? Right? Like, so let's take a look at, like, let's actually print this out. So let's go print D dot underscore class dot MRO Judas. There we go. And see, well, what does that yield? And I mean, technically, I guess you could just go like this if you want to. I'll show another example of it. So let's print this. Bow. It goes D, B, C, A. That is the order. So you learn that D, B, C, A, that object, which means that when you ask for a D level, you get C, which is incorrect. You'll always get B. So in day-to-day programming, it's not common to have to deal with MRO, but it is important to know, just if you ever get in some weird, complicated situation, that you'd be able to find your way out by just returning the method resolution order. So, yeah, fun little thing. If you got any questions on it, let me know. But if not, then we'll move on to the next thing.